Hi and welcome to my video. So in this video, we are again going to compare ArrayList and LinkedList. We are going to do performance benchmark. So we have seen that ArrayList object retrieval operation in ArrayList in worst case is way lot better than linked list. It's because ArrayList is a continuous memory allocation and linked list uses internally doubly linked list to store the data. But if you look at the differences, across various websites, you will see that manipulation with the ArrayList is slow. It's because it uses an array and all elements, they have to shift one step ahead in the memory. That's why manipulation is slow. Whereas in linked list, the manipulation with the linked list is faster. So we are going to see today if that is true, for larger data. So the assumption, we are expecting, as per theory, that ArrayList should be slower compared to linked list when you do manipulations. All right, let's go to the code. So we'll create linked list again, just like in last session, and we'll be creating ArrayList. All right. So let's create one int stream, just like in last session. We'll use int stream to uh, create some random data. Okay, for which let's take a number. Let's add it uh, into both data structures. Okay, now let's start with our first operation, that is linked list dot add. So first take index. We want worst case, since it's a doubly linked list. We'll have to find middle. Okay, so that it will take maximum time. Then uh let's do ArrayList dot add index and same operation. Okay, so let's have our benchmarking variables. Start time system dot current times in millis, long end time equal to system dot times in a millis, and let's print it over here. Time taken for LL is end time minus start time plus milliseconds. Let's print it over here. Let's initialize start time again, and let's initialize end time too. Okay, and here I'm going to make L. Okay, so similarly, so time taken for this is time taken for LN add operation, right? This is insert operation, and here also it's an insert operation. What we are going to do is we will also remove, okay, from both data structures, and let's see, we'll be comparing the performance for insertion and removal. So for that, I need to remove from the, again, we have to consider worst case. So we'll be removing exact element at the middle. Okay. So yeah, maybe time taken for remove. Okay. All right. So let's run this code and see. Let's see what is the output. Okay, so we can see linked list is actually taking a lot of time than array list. We'll run it again and see. So you can see there is a lot of difference between performance of linked list and array list when even when we try to insert or when we try to remove. So theoretically, we say that you can go to any website or book, they'll say that manipulation is better. But when we go to large data, we actually need to find out the reason. So what ArrayList does is doesn't it. So our assumption here was that whenever element is removed from array, all the elements are shifted. But if you look at the implementation, actual implementation of ArrayList, what it does is it actually uses system array copy. So it's not shifting. What it does is it makes use of enormously available memory. So what it does is simply copies the whole array except that that the index. So it's actually beating linked list for insertion as well as remove operation. So even in case of remove, what it does is it simply does the same fast remove operation. Here it uses system.arraycopy. So very important that whatever we have been taught in a theory, it actually the benchmarking or the real result is actually